Do you want to answer? Yeah. And beta k. Usually you may see it in C. So I picked a simple example, but this is just to illustrate that every time we deal with an ODE, maybe we want to think about the original physical system. And you're also familiar with this system. Also, this is the output force, sometimes represented by F or more often by U. And X means the displacement of the mass. We consider this mass as a single mass point instead of a mass with volume. And let's look back at the original system that we usually use. This system is the Laplace transform of this. And this will be the Laplace transform of the input, Laplace transform of the output, and what should this transfer function? Oh, I'm sorry. This is a transfer function, and the transfer function will be what for this case? 转移就是我们讲的转移函数。那这边只是在复习说我们转移函数怎么样对应到一个时域的方程式。The transfer function is a function of S, which represents frequency. Okay, I'm gonna pick someone to answer. 看咯，知道吗？可以吗？想得到吗？还是别人？ anyone from Zhongyang? They have moved.那边的同学来帮忙回答这个问题吧。就是你们在画面上看到的这个转移函数，在现在这个情况下应该是什么？不对，他们不能回答。 而且助教也不能打这种字。那，好啦，那你知道吧？或是大约长相？你知道？ 还是你看起来好像没有在思考的人，所以应该已经知道了。就是假如我的 input 是这个 output 就是它的位移嘛，然后参数已经都给啦。那以前我们都是控制都是在讲转移函数，那这边的转移函数大概长什么样子？大概哦。Anyone want to answer this question? Let me repeat. What I'm trying to let you recall what this transfer function may look like in this particular case of the mass spring dashpot system. Yes, it's a function of S. Okay, good. I have some input from students now. It will look like this. Okay, and the coefficient will match with. Okay, can you read what I'm doing here? It's 1 over ms squared plus beta s plus k. So this is just to strengthen your concept of their relation. And whenever we work with this system here, you have an automatic connection between the other two. Let's go back to the main slide. These are two even simpler systems. The first one is the pendulum system, and then next one is the spring system without any damping. With Newton's law or the Lagrange equations, you can derive the equations of motion. So both of them should be very familiar and very simple. There should be a bar here, but there is a difference between these two equations, and the difference is one is a linear equation, one is a non-linear equation. So is this pendulum system a linear system or a non-linear system? Non-linear, right, from the equation. So do not get confused because you see a line here. It's actually a non-linear system. And you see a spring here, but it's a linear system. As we mentioned earlier, for many non-linear systems, there are no exact solutions. For this one we do have, but will be a very complicated solution. Therefore, we usually work with the linearized equations. So what you more often work with is the linearized equation of the pendulum system. This is not